type in the stock ticker of your choice, investing.com, and then price history, and then you click on the website. You see here you can choose daily or monthly. I would choose monthly, and I would use a 10 years period from 2015. And then I can click download and have the data. I will only use the column price, and I paste it into another worksheet here and change the name to do the same thing for other stocks. And for gold, it would be just the same steps. And after you collect all the data, you would have the data table just like me here. Step 2, calculate return, standard deviation, and covariance. So first, you would need to calculate the change in price of these 6 assets. In order to do this, you would take the price of this month minus the price of last month and divide it by the price of last month. And then same things. And then you get the data table for change in price. For me, I want to change it into percentage. One thing to note here for the return and the standard deviation, it should be annualized. So to do that, I would take the price of this current month. I divide it by the price 10 years ago. And then this one to the power of about 12 over 120 because it's 10 years. And then you minus 1. Then you would do the same thing for other 6 assets. For the standard deviation, you would use the standard sample formula for the change in price here. And then you would multiply it by the square root of 12. And for the covariance, one thing I want to say here is that if you're using older version of Excel like me on MacBook, for example, to use the transpose function, you would need to choose the array here, 6 rows, and then you would type in function. You would need to hit Control Shift Enter. There you have it. And for the covariance, I would use the data analysis tool in the data tab, and then data analysis, covariance. The input range would be the change in price data table. And then you hit enter. And then you have the covariance table here. You just copy it here. You will need to complete the covariance table here. For example, this one, VHC and DNM, it was equal to this. So now you already have the return, the standard deviation, and the covariance table. The next step would be to find the minimum variance portfolio. So we have here the weight of each asset, and then we have the return of the portfolio, the risk of the portfolio. The risk here is the standard deviation. So for the weight, I would just assume it's equally weighted here. For the return, I would use the sum product function to take the weight multiply with return. And for the risk, I would use the MULT function. This is like matrix multiplication function. If you want to understand like more the logic behind this function, I suggest you go to ChatGPT to understand, matrix multiplication from the start. And for this calculation, I would need to take the weight and then another MULT function inside, the covariance table, and then the transpose of the weight. So this is a variance, a covariance. You need to multiply by 12 to analyze, and then in order to get the standard deviation, you would need to take the square root of it. You will see here, this is like an arrow because I'm using the older version of Excel. So in order to calculate the matrix function like this, the array function, I would need to hit Control, Shift, and Enter. And then there you go. You would have the function set in already for return and risk. Next, in order to find the minimum variance portfolio, you will need to use solver here in data and then solver. The objective here would be the risk. You want the risk to be minimized by changing the weight of each asset here. And the constraint would be, so the weight of each asset, it should be greater than 0, equal or greater than 0, right? And then another constraint would be for the sum of the weight to be equal 1. Another constraint here, the sum equal 1. And then hit solve. And then you have it. Result for our minimum variance portfolio is here. The return, the risk. Step 4, find the optimal portfolio. You will need to save the minimum risk portfolio that you just find by using paste special. And for the optimal portfolio, you will need also the risk-free rate. To find the risk-free rate, I also use investing.com and I get the number 3.2%. Another thing that you also need to calculate is the Sharpe ratio. So the Sharpe ratio is the excess return over the risk that you take. So it's the return minus the risk-free rate over the risk. The higher the Sharpe ratio, the better. And that's why we need to maximize the Sharpe ratio for the optimal portfolio. Using solver again. So this time the objective is the Sharpe ratio to the maximum. The constraint is also the same. You just hit solve. And with that, we have our optimal portfolio here. This is the risk and this is the return. the return. The final step, we almost done, guys. Great job. So you would do the same things. You would copy the optimal portfolio here to save the data. And then here I have efficient frontier to help you visualize how would we draw it. So the red point is the minimum risk portfolio. The yellow point is the optimal portfolio. You can notice that the red point is the turning point. So in order to draw this, you would need the data for each of these points. And to do this, we would use solver. So first, I'll just copy the minimum risk portfolio here and the optimal portfolio here. And then I would take just deviate it in both way. So here I have 8%, 7%, 6%. Here I have like 12, and 12.5 or 13. Yeah, and I will open solver. The objective now is to minimize the risk. Because each of these points here, this is the minimized risk portfolio at that return. So you have to minimize the risk, and you add another constraint for the return to be exact, like for example at 8%. So if you roll the okay and hit solve. And with that, I have a return of 8%. The risk is 12.3. I will place special here. And I would do the same things for other points as well. For example, 12%. Solver again, I would change the value to top again. Take a little bit long because the solver takes time to solve. There you have it. 15%. You paste it here. So I got the solver for all these points, and I have this data. Now I will graph it and select this and insert. This will be a starter block. So you will see that the graph it look a little bit off. It is because you need to select the data. For the x value, the horizontal line, it would be the risk. And for the return is the y value. Okay, yeah, there you have it. The shape like parabole of the efficient function. You can change this to 0 decimal. Here, number, and then like 0, in the size. And you can also increase the size of the marker option to this turning point here. It is our minimum risk portfolio. This point here is our optimal portfolio. So, well, after that, we can draw the capital allocation line. The capital allocation line is a line between the optimal portfolio and the risk-free rate. So I copy the optimal portfolio here, and I also input the risk-free rate point. The return is 3.2, and the risk is 0. And then I will hit chat design, select data. I add another series here. So the x value will be the risk. To this, this, and this. And then there you have it. And in order to create a line, you just click these two points, go to solid line. Then with that, we finish. We have the variable, efficient entire here, capital allocation line here. This line can go beyond this, like this. I know that this is a simple illustration. There are other tutorials that they can help you create like 10,000 simulation. But I think this is like simple, but it also help you to try to visualize the shape of the entire, you know, where the optimal portfolio and the minimum risk portfolio is. So thank you for watching.